Good morning or good afternoon, Tigers. Today we'll be watching a video on Math Notes page 38. Let's say you have something on Math Notes page 38. Go ahead and turn the page and do it on page 39. I'm not concerned with the number. I'm just concerned with you doing your work and you doing it neatly. Please title this page Angles. You're going to divide this up into 3 sections. So typically we just divide it up into 2 sections, which is Cornell note style. But today we're doing something different. So you're going to have one section for just a vocabulary term or the word. And then you're going to have a section for the actual definition, which is the justification or the explanation. That's why I put SMP3. And then we're going to construct the actual geometric figure, which is model with your math, SMP4. So because YouTube doesn't let me upload videos that are 10 minutes or longer, I'm going to be pausing my videos, writing everything out, and then explaining it. So you're going to have to keep pausing in order for you to write things down. So I could have recorded 20-30 minutes of me talking, but we both know you don't want to sit here and listen to me for 20-30 minutes when you guys can just pause it and write it down. So I'm going to be doing that. Please make sure that you're on task. I wouldn't recommend muting me because you won't know when to pause. Okay, so this is a perfect example of our first vocabulary term, which is an angle. The definition is, or the SMP3 of it is, an angle which can be written like the less than symbol, but that doesn't mean less than in this case. Whenever you see the less than symbol with letters next to it, that means angle. It doesn't mean less than. So an angle, which is denoted like that, is a figure formed by 2 rays with a common endpoint. These right here, so AB is a ray, BC is a ray, or CB is a ray. But see, they connect and they both end at this point, which is B. So this is considered an endpoint. You can name this angle ABC or CBA, or you can just say this is angle B, or you can say this is angle 1. Depending on what information they give you is how you would write your angle. So let's say there's you don't have A, B, or C, but you have this angle and you have a number. So then you would say that this is angle whatever that number is. Okay, moving on. So some of you might remember this from 6th grade or elementary school. An acute angle or a triangle is an angle that measures between 0 and 90 degrees. Basically, less than 90 degrees. An acute triangle is a triangle with all angles less than 90 degrees. And please note the way I wrote less than. Remember, it's the less than inequality. I'm going to try to always review the previous unit so that you guys do not forget it. So just always get into the habit of writing less like an inequality in math and greater than as well. So the angle measure in the acute triangle, all of the angle measures are less than 90 degrees. So it can be 89, 89.9, 89.99. Anything that's less than 90 degrees is considered an acute angle. So this triangle right here would be considered an acute triangle. Let's add up all the angle measures and see if they add up to 180. 50 plus 50, 50 degrees plus 50 degrees is 100 degrees. 100 degrees plus 80 degrees is 180 degrees. So this is indeed a triangle, but it's an acute triangle. And acute triangles still equal to 180. All triangles equal to 180. Acute triangles, equilateral triangles, scalene triangles, obtuse triangles, right triangles, all triangles, if they're truly a triangle, they're going to be equal to 180 regardless of their classification. So a right angle or a triangle is an angle that measures exactly 90 degrees. A right triangle is a triangle with one angle that equals 90 degrees. So if you look at the angle to the right, it kind of looks like half of a square. Well, a square and a rectangle has angle measures of 90 degrees. Remember, when you have a square or a rectangle, they have equal sides. So if it's a square, they have all equal sides. If it's a rectangle, they have 2 sides that are congruent. So these 2 sides would be congruent and these 2 sides would be congruent. That's not what I wanted to teach you. What I wanted to teach you is that in a square and a rectangle, they have kind of like an L shape, and that means they have a 90-degree angle. So in math, we translate that as a 90-degree angle. And if you see this little box on an angle, that just means 90 degrees. So for instance, if you were to see this triangle and you weren't given any angle measures, you would at least know that this box right here, or this half of a box, is 90 degrees. Now these two other angles are congruent. That's why I put a little line through them. So I do this little angle measure and then I put a little line or a dash through it. And if I have another angle measure that has a dash through it, that means that they're congruent. They're equal or equivalent. So if this is 45 degrees, you can assume that this would be 45 degrees. So now let's add this together and see if it's equivalent to 180 degrees. 90 plus 45 is 135. 135 plus 45 is 180. You can check me on a calculator if you'd like, or you can just trust me. Okay, term 4. An obtuse angle or triangle is an angle that measures between 90 degrees and 180. Really, it's an angle that's greater than 90. So let me write that over here. Greater than 90 degrees. So it's an angle that's bigger than 90 degrees. An obtuse triangle is a triangle with an angle measure greater than 90 degrees. So remember, pay attention to the way I write greater. I write it with my inequality so that I remember what direction my inequality goes. Here's an example. This is a 91 degree angle, so it would be considered an obtuse angle. Now, if it was in a triangle, it would be considered an obtuse triangle. Here's an example of an obtuse triangle. We have 120 degrees, 20 degrees, and 40 degrees. Do you guys see these little dashes right here? So this has one dash because there's not another one that has 40 degrees. So since there's no other angles with 40 degrees, I can't do a one dash anymore because that would mean that they're equal. So look at the 20 degree dashes. There's two of them because two dashes is different from 1 and 3. There's not another angle that has 20 degrees, so that's why I do my two dashes right there. And then 120 degrees, there's no other angles that are in there that are 120 degrees. If there were, it wouldn't be a triangle because it would exceed 180 degrees. So now let's check if this triangle is truly a triangle. 40 degrees plus 120 is 160. 160 plus 20 is, in fact, 180 degrees. So this triangle is also a true triangle. Wow, we have written a lot of notes. So if you run out of room, go ahead and turn the page. I don't care how many pages you use as long as it looks nice. I'm very proud of myself. This is very neat. This is better than me writing in person under the Elmo. So please take advantage of this. If you need to pause it, reread and annotate your notes, I suggest that you do that. So I'm going to turn the page on this thing because I don't want to continue this document here. So an isosceles triangle is a triangle with two congruent sides or equal measures. So sometimes what I do when I introduce you to a vocabulary word is I give you a thought bubble to tell you what it means in another word. So congruent just is another word for equal or equivalent. So here we have an example of an isosceles triangle. We have an isosceles triangle or a triangle that has two equal sides. The side measures are 5. We can say 5 centimeters or 5 inches. It doesn't matter. It's not to scale. And then we have two angle measures that are also congruent or equivalent, which is 50 degrees. This little line on these sides means congruent. And this angle with the dash, which I've already explained to you on the other slide, is considered congruent, is considered a congruent angle or congruent angles. An equilateral triangle is a triangle with all sides and all angles congruent to one another. So here's a perfect example of an equilateral triangle. All the sides are equal to 7, and all of the angles are congruent, and they're equal to 60 degrees. A scalene triangle is a triangle with no congruent sides and no angles, or no congruent angles. Here you see an angle that has 3 dashes. Do you see another angle with 3 dashes? Nope. You also don't see another angle with that same measure. Here we have another angle with 2 dashes, and here we have an angle with another dash. You might say, oh, this angle is equivalent to this side. Well, technically in upper division geometry, this angle can give you the measure of the side, but degrees and centimeters or measurement are not the same thing. So if you had inches right here, 3 inches is not the same as 3 degrees. Completely different. This just means that they're corresponding. So this angle corresponds to this side, but they're not equal. It also means this side cannot equal this side, nor can it equal that side. This angle can't equal that angle, or that angle can't equal this angle. This is just showing the differences. So now please write this down and write in your notebook which angle or triangle is your favorite. Why? Go ahead and draw it and have some fun. Please remember to follow the appropriate social skills while you have a substitute teacher. Please make me proud, stay on task, follow instructions. If you finish early, you may work on the W exercises on iExcel. If you forget your login, go ahead and raise your hand and Miss Trujillo will help you.